several examples of the graph of a function of two variables would look like. So for example, here on the textbook, we see I have a function of x and y defined as square root of 4x squared, square root of 16 minus 4x squared minus y squared. So it looks like an upside down ball or ellipsoid, if you will. Okay, so we also know that if it is a function of 3 variables, then we actually would have trouble to graph it out on computer or on a board. It's just not possible because I don't have a 4-dimensional space to sketch that. So we're gonna then introduce a very important concept called level sets, and depends on the dimensionality. Sometimes we call it level curve or level surface. Usually we say like level curves because we want to see a bunch of them, as well as the level surfaces. Okay, so what is a level curve? If I have a 2-dimensional surface, as you can see here on the left, if I say I want to find the trace on this surface with a specific given height. So for example, I only want to know what part of the surface has height exactly equal to 2, for example. Okay, so then you can imagine now, if you have a knife and you are good at chopping, then you can say I then chop through this surface horizontally at z equal to 2. Then the trace, which is this curve in red, would be the so-called level curve to this surface with z equal to 2. Okay, all right, so what does that mean then? Like, why do you want to know this? All right, imagine you go hiking, or if you're watching 4K kids on the internet or the TV, then sometimes it's easier to use level curves to represent a 3-dimensional graph. Okay, or like a 2-dimensional surface in R3, if I want to be a little more precise. Okay, so here's an example. We have a mountain over here. Okay, which mountain is it? It says the mountain. Okay, it doesn't say which mountain. I was just curious. Okay, so we have a mountain. Okay, so you can imagine. All right, so suppose locally, we only care about locally. We don't care about what happens on the entire universe, not entire Earth. So just a small region. So you can think that it's the surface of this mountain is a function, the graph of a function of 2 variables, right? So you have like x, y, in the like down here, right? And for each x, y coordinate, for each position, you have the associated height up here, right? Okay, and here you have the associated height over here. All right, so say if you're going hiking, and this is figure 13.7 is the figure you get. Yeah, you print it out on a map, but you will figure that it's not very useful if you're like in the middle of the mountain, because it only tells you like one side of the mountain looks like, right? So not very useful, to be honest. So what if now that say I just decided to cut through this surface, okay, and sketch out its level curves, and now I drew the level curves on a 2-dimensional map, and let's see what happens. So each curve is a level curve with a specific given height, as you can see the number here. Okay, so now you can see that so this is the height is evenly spaced. Okay, so you can see that 6600 is along this curve, like I'm tracing it, right? Okay, and then it goes like higher and higher and higher, and up here it's 7800, okay, feet, I believe. Okay, so now as you can see, if the level curves look looser on this two-dimensional map, what does that mean? It will mean that the mountain along here, like this trace, is less steep, right? And here, the level curves are very dense, right? So what would that be on the map? So that's like, as you can see, it's this part, like very steep, okay? So if I only get to choose a map in between these two, when I enter the mountain, I would definitely use the one on the right, because it tells me way more information as opposed to the one on the left, okay? So this is like one way you can use level curves to tell you extra information, okay? Like I used a bunch of one-dimensional curves all together, and I, like in my brain, I put them together and I can tell information about this two-dimensional surface in R3, all right? Okay, and similarly, depends on the meaning of the function, right? So I could say, again, x, y is the coordinates for position, right? And the output value means, like, let's say temperature. Then I can have level curves show the lines of equal temperature, okay, measured in Fahrenheit, for example. Okay, so now you can see that this is like way hotter and gets colder and a little hot and a little cold, like that, right? So instead of looking at the surface of the temperature, we can just look at the level curves of the temperature, for example. Okay, so that's why we care about level curves. And of course, if I have a function of three variables, then it's gonna be something in R4, right? I don't know what it looks like. So in that case, we can say, okay, what happens to the level surface? Okay, all right.